In our lessons with expressions so far, we've been using the commutative property to rearrange our terms, and we've been using distributive property to generate equivalent expressions. And we're going to work with equivalent expressions here today when we factor expressions, okay? A factor is a number that is multiplied by another number in order to get a product, okay? But to factor something as a verb, to factor means to write a number or an algebraic expression as a product. Okay, and you've done this before in elementary school. If I look at the factors of 12, that means I'm going to take 12 and write it as a multiplication problem. Okay, so one way that you could make 12 is by doing 1 times 12, which is the same as 12 times 1. You could also do 2 times 6, which is the same as 6 times 2. And you can do 3 times 4, which is the same as 4 times 3. Okay, all of these are the factors of the number 12. So we'll put them in order. I would have 1, 2, 3, 4, 6, and 12 as my factors. Okay, to factor 16, again, I'm going to write 16 as a product, so I could do 1 times 16. I could do 2 times 8, and I could also do 4 times 4. Okay, so that means that the factors of 16 in order would be 1, 2, 4, 8, and 16. Notice that I don't have to list both of the 4s. I can only write it one time when I list them in order. Okay, so we've just found the factors of 12 and we found the factors of 16. If I were interested in finding the common factors of 12 and 16, I would look at the numbers that are in both lists. Okay, and I see that they both have a 1, they both have a 2, and they both have a 4. All right, so the common factors are 1, 2, and 4. The greatest common factor, also known as the GCF, would be the number 4. That's the biggest number that appears in both lists. The GCF is going to be very important later on when we're factoring our algebraic expressions. So we just did a nice review about how to factor numbers. What we're going to do in our next example is factor an algebraic expression. Question 3a says to factor 6x plus 18. In order to do that, we're going to find the factors of each term. So we're going to find the factors of 6x, we're going to find the factors of 18, and then we're going to talk about their common factors. All right, let's start with the factors of 6x. Now, for just a moment, I'm going to ignore the x and I'm going to think about the factors of 6. One way to make 6 is if you do 1 times 6. Another way to make 6 is if you do 2 times 3. All right, so that the common factors, the factors of 6 would be 1, 2, 3, and 6. Now, since it was 6x, all right, in addition to having the factors of 6, I'm also going to put a variable x in that list as well. 1, 2, 3, 6, and x are the factors of 6x. To find the factors of 18, well, I could do 1 times 18. I could do 2 times 9. I could also do 3 times 6. So if I list the factors of 18 in order, I would have 1, 2, 3, 6, 9, and 18. Now I'm going to look at both lists and identify the common factors, okay? I see a 1, I see a 2 in both lists, I see a 3, and I see a 6 in both lists. So the common factors are 1, 2, 3, and 6. 3b says, hopefully you found hopefully you found 3 common factors besides the number 1. And in fact, we did. All right, we found 2, 3, and 6 are the common factors. What we're going to do is write 6x plus 18 as a product using the common factors that we found. So our common factors could be 2, we also said could be 3, and could also be 6. Okay, here's what we're going to do. We're going to write 6x plus 18 as a product using the common factors. So let's start with a common factor of 2. 6x plus 18 is going to be equal to 2 times something else. We have to figure out what that other factor is. The way that you get the other factor is by taking our expression and dividing each part by that factor that they have in common. So if I had 6x plus 18, I would divide each part of it by 2 in order to get the other factor. 6x divided by 2 is 3x, and positive 18 divided by 2 is positive 9. So 3x plus 9 is going to be my other factor. 2 times 3x plus 9 is equivalent to 6x plus 18. Okay, so what we've done here is kind of done the distributive property in reverse. I've taken my expression and I've written it as a product, 2 times 3x plus 9. If I use my common factor of 3, I'm going to have 3 times something is equal to 6x plus 18. Well, again, in order to figure out what that is, I'm going to take each part of the expression and divide it by the common factor, which this case was 3. 6x divided by 3 is 2x, and 18 divided by 3 is positive 6. So 3 times 2x plus 6 is equal to 6x plus 18. Finally, if I use the common factor of 6, 6x plus 18 is going to be equal to 6 times something, but let's figure out what the other factor is. I'm going to take each part of 6x plus 18 and divide it by 6. 6x divided by 6 is x, or 1x. You can put the 1 there if you want. And 18 divided by 6 is 3, a positive 3. So 6 times x plus 3 is equal to 6x plus 18. So we've just found 3 different ways to factor this expression. C asks, which of the factorizations uses the greatest common factor, or the GCF? Well, that was the last example that we did, where it was 6 times x plus 3. That factorization used the GCF. D asks, how could you check to make sure if your factorizations are correct? If I wanted to make sure that this is equal to 6x plus 18, I could always distribute. If I distribute, I should get what I started with. 6 times x, or 1x, is equal to 6x. And 6 times 3 is equal to 18. So I know that 6 times x plus 3 is equal to 6x plus 18. In example 4, they want me to factor the expression 4x minus 8 2 different ways. And so what I'm going to do, I'm going to find the factors of each part of the expression and then look for their common factors. So let's start with 4x, okay? Well, the ways that I could make 4, I could do 1 times 4, and I could do 2 times 2. So the factors of 4 are 1, 2, and 4. And now, since there's a variable x as well, we're going to include that as a factor. 1, 2, 4, and x are the factors of 4x. For the factors of 8, for 8, I could do 1 times 8, or I could do 2 times 4. So the factors would be 1, 2, 4, and 8. Now I'm going to list the common factors. If I look at my 2 lists, I see that they both have a 1, a 2, and a 4. So those would be your common factors, 1, 2, and 4. Now, they've asked me to factor 2 different ways, but notice there are 3 different factors. Well, the factor that we're not going to use is 1, because when you divide by 1, you just get what you started with. So we're going to use the factors of 2 and 4. So this one's going to start out as 2 times something, and this one's going to start out as 4 times something. If I use the factor of 2, 2 times what is 4x minus 8? Well, again, I would divide each part of the expression by 2. 4x divided by 2 is 2x, and negative 8 divided by 2 is negative 4. So 2 times 2x minus 4 is equal to 4x minus 8. If I use the common factor of 4, again, I'm going to divide each part by the common factor. 4x divided by 4 is x, or 1x. Negative 8 divided by 4 is negative 2. So 4 times x minus 2 is also equivalent to 4x minus 8. Each answer above shows a correct way to factor 4x minus 8, but one of them has been factored better than the other one, okay? The product of 4 times x minus 2 shows that the expression has been factored completely. All right, 4 times x minus 2 has been factored completely because it uses the GCF. This means that each term in the parentheses can't be factored anymore. If I look at what's in the parentheses, the x and the minus 2, their only common factor is a 1. But again, if you divide by 1, nothing's going to change. If I look at this example and what's in the parentheses, 2x and the negative 4, Notice that they still have a common factor of 2. So I would still be able to divide each of these by 2, meaning that this has not been factored completely. But when you use the GCF, you have factored completely. So when the directions ask you to factor completely, make sure that you factor with the GCF. In example 8, we're going to factor 25 plus 10h. So let's look for the factors of each part of the expression. The factors of 25, you could do 1 times 25 or 5 times 5. So 1, 5, and 25 are the factors. For 10h, all right, to get 10, you could do 1 times 10 or 2 times 5. So we would have 1, 2, 5, 10. And since there's an h there, we'll add h to the list. The GCF, the biggest factor in both lists, notice, is the number 5. So 5 is the GCF. So for our factored form, it's going to start out as 5 times something. To get the other term, divide each part by 5. 25 plus 10h, divide each part by 5. 25 divided by 5 is 5. 10h divided by 5 is a positive 2h. So our factored form is 5 times 5 plus 2h. Again, you can always distribute to do a check. If you use the distributive property here, you would do 5 times 5 plus 5 times 2h. 5 times 5 is 25. 5 times 2h is a positive 10h. And notice that that expression matches what you started with up here. So this expression has been factored completely, 5 times 5 plus 2h. Another method of finding the GCF is something called the ladder method. You may have used the ladder method back in elementary school, okay? Sometimes the numbers are very big and we can't think of all the factors, but if we use the ladder method, that's going to help us identify the greatest common factor. Okay, so what I'm going to do, if I had the numbers 12 and 16, I'm going to put like this upside down division box there. And I'm going to look for any number that's a factor of 12 and 16. Looking at both of those numbers, they're both even, so I know that 2 would be a common factor. I'm going to divide each one of these numbers by the 2. 12 divided by 2 is 6. 16 divided by 2 is 8. Now I'll do the same thing with the numbers 6 and 8. They're both still even, so I know that 2 is a common factor. 6 divided by 2 is 3. 8 divided by 2 is 4. Now I'll do the same thing with the numbers 3 and 4. Okay, and I'm looking at those and I'm thinking, do they have anything in common? Well, they actually do, but it's the number 1. And when you divide these numbers by 1, they're not going to change. So I'm going to have my 3 and my 4 again. So this tells me that I've taken out all of the common factors. Now, to get the greatest common factor, I'm going to look at the numbers that are on the outside, and I'm simply going to multiply them together. 2 times 2 is 4. 4 times 1 is still 4. So the greatest common factor of 12 and 16 is equal to 4. All right, we could also do that with 27 and 36. Any number that's a common factor. Okay, well, you might notice that they're both divisible by 3. 27 divided by 3 is 9, and 36 divided by 3 is 12. If I do the same thing for 9 and 12 now, well, again, both of those numbers are still divisible by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. And hey, there's my 3 and 4, just like I had over here. So I know it's 1 is their only common factor. And now if I take these numbers on the outside and multiply them, 3 times 3 is 9, times 1 is still 9. The GCF of 27 and 36 is equal to 9. The latter method that we discussed above can also help us factor linear expressions. Okay, so that's what we're going to do in example A. We have 4x plus 12. I'm going to put my ladder around both of those. And I'm looking for anything that's a common factor of 4x and the 12. And looking at these, again, I see that they're even, so I could use 2 as a factor. 4x divided by 2 is 2x. Positive 12 divided by 2 is positive 6. So now we have 2x plus 6. All right. Now I look at 2x plus 6 and realize, again, they're still even, so I could use 2 as a common factor again. 2x divided by 2 is x, or 1x. 6 divided by 2 is a positive 3. So we have x plus 3. And now if I look at x plus 3, which is the same as 1x plus 3, I notice that they only have a common factor of 1, which again is going to get me back to x plus 3. So my greatest common factor, if I look over here on the left side, 2 times 2 is 4, times 1 is still 4, so my GCF is 4. 4x plus 12 is going to be equal to 4 times something, all right? To figure out what the other factor is, all you have to do is look at what was left over. In this case, it was the x plus 3. So 4 times x plus 3 is how you would factor 4x plus 12. All right, let's do that in letter C. We have 12a minus 18b. All right, a common factor. Well, I see that they're both even. I could use 2. You might also notice that 3 is a common factor. You might also notice that 6 is a common factor. Let's go ahead and use the 6. 12a divided by 6 is 2a. Negative 18b divided by 6 is negative 3b. Now when we use 2a minus 3b, a common factor for those, well, I only see 1 as a common factor, which means I'm going to have 2a minus 3b again. And now to write my answer in factored form, I'm first going to get the GCF, 6 times 1, which is 6, times the other factor is here at the bottom, 2a minus 3b. All right, 12a minus 18b in factored form is 6 times 2a minus 3b. In the box, we have a special case that we're going to talk about. They want us to factor 12x plus 7y. So if I go ahead and use my ladder method here, all right, I'm looking at the two terms, 12x and 7y. And for a common factor, the only thing that I notice is the number 1. But when you divide by that 1, again, nothing changes. You still get 12x plus 7y. There is no other common factor besides the 1. So 12x plus 7y, I mean, you could technically write it as 1 times 12x plus 7y. But again, they're the exact same thing. This is a special case because the GCF is 1. When the GCF of two terms is 1, that should say is 1, okay, the terms are called relatively prime. Relatively prime. All right, so if you're working through an example and you notice that they only have a greatest common factor of 1, we would call those terms relatively prime. In example 13, we're again going to factor using the ladder method. So let's go ahead and put our ladder around the two terms in our expression, 6n plus 15mn. Okay, and so I'm looking for a common factor that these two terms would share. So looking at the numbers 6 and 15, I know that they're both divisible by 3. So when we divide 6n divided by 3, we're going to get 2n. And when we divide positive 15mn by 3, we're going to get a positive 5mn. Okay, so now I'll use my ladder around 2n plus 5mn. And if you look at the numbers 2 and 5, you might notice that they don't have a common factor besides 1. However, if you look at both terms, notice that they both have the variable n in them. Variables can be common factors as well. So I'm going to divide each term by the variable n because n is in each term. 2n divided by n is just the number 2. 5mn divided by n is just 5m. So we end up with 2 plus 5m. Now when I look for a common factor for 2 and 5m, notice they don't have any variables in common anymore. And we said that 2 and 5 only have a common factor of 1. So again, that's going to leave us with 2 plus 5m. So to get our factored answer, I'm going to start with the GCF. So I'm going to take what's on the outside and multiply. 3 times n is 3n. 3n times 1 is still 3n. So I'm going to have 3n times, and the other factor is down at the bottom of the ladder, which was 2 plus 5m. So 6n plus 15mn in factored form would be 3n times 2 plus 5m. We can do the same thing with 12cd minus 15c. A common factor for the numbers, they're both divisible by 3. 12CD divided by 3 is 4CD. Negative 15C divided by 3 is negative 5C. So we have 4CD minus 5C. All right. They both have a variable C in common, so let's divide by C. 4CD divided by C is 4D. Negative 5C divided by C is just negative 5, and that gives us 4D minus 5. And looking at a common factor for 4D minus 5, well, again, that's just going to be the number 1. Now to write our answer in factored form, well, GCF, 3 times C times 1, is 3C, times the other factor is at the bottom of the ladder, which is 4D minus 5. In completely factored form, 12CD minus 15C is equal to 3C times 4D minus 5.